Hello, this is from SSSCE, Commerce 1993, objective question number 27, and we want to look at it. It reads this way: P, Q, and R are subsets of the sets 2, 3, 4, 5, 6, 7, 8, 9. If set P equals X is such that X is less than 6, and set Q equals Y is such that Y is greater than 3 but less than 8, and set R is equal to the set of even numbers, we are to find P intersection Q intersection R. So we have to be very careful here. Now, most students make mistakes here. Now, the first thing that we have been told is that we have three sets. So let us name these sets. We have the set P, we have the set Q, and of course we have the set R. And we are told that all these three sets, they are subsets of a set of elements which comprise 2, 3, 4, 5, 6, 7, 8, 9. So in other words, that is our universal set, because we are told that we have three sets P, Q, R, and all these sets are subsets of this. That is to say, all these sets can be found in this bigger set. So if we have just three sets, that is P, Q, R, and they are all subsets of this set, then this set is the universal set. In other words, any element in the set P or Q or R must also be in the universal set. So, if I was to, illustrate it with a Venn diagram or diagrammatically, let us assume that these sets are disjoint sets. So we have P in it, the set P is here, and we have the set Q also here, and we have the set R also here, all in this universal set. Do you see that? So if you have something like some circles to represent the set, so whatever is in P must also be in the U, whatever is in Q must also be in the U, whatever is in R must also be in the U. As to the intersection between P, Q, and R, we are yet to find that. And of course, because the question even asks us to find P intersection Q intersection R, we can even begin to think that this tells us that there is intersection among the three sets. So we can draw a better diagram this way. We can have something like this. You have the set P, and maybe let me use a black ink for the set Q, and of course we have another set, so let this also be the set R. So it's something like this, because we've been asked to find P intersection Q intersection R, and let me put a rectangle around it so that we have the universal set. So it's something like that. So if that is the universal set, and of course we are told that these three sets, the set P and that of the set Q and the set R, they are all subsets. They are subsets. We see the word here, subset. So that means that P is a subset of U, Q2 is a subset of U, and the set R is a subset of U. So that is to say that any element or member that you will put in the set P or Q or R must also be part of the U. All right, let's start to solve it. First, we look at the P. What statement do we have here? The statement that we have is that P, the set P equals X is such that X is less than 6. Now, that is to tell us that the elements in the set P should be elements that are less than 6. So what numbers are less than 6? X is less than 6. Okay, 5 is less than 6. See, you can see that I'm starting from the right to the left because I'm looking for numbers that are smaller. I am not writing incrementally. I am decreasing my numbers. So another number that is less than 6 is 4. And of course we have 3, and we do have 2. Are you going to write 1, 2? Of course 1 is less than 6. Are you going to write 0, 2? Of course 0 is less than 6. But we cannot write 1. We can't write 1. We can't write 0. We can't write -1. All these cannot be here. Do you know why? Because the set P is a subset of this set, the universal set. And within the universal set, there is no 1. So if I put 1 here, that makes my set P incorrect. Do you get it? So the set P will be just 2, 3, 4, and 5. So that's all the set P. So this is very important because the universal set kind of it delimits the set that has been given to you. It shows where the set should end, where it should begin, and where it should end. Now let's go to the set Q quickly. The set Q also says that Y is such that, you see, we have a value on the left and 1 on the right. So we start to read from the middle. So Y is such that Y, then we begin from the smaller one, that is the one on our left hand side. Y is greater. You know, when the sign faces the variable becomes greater. That is what I'm trying to say. For example, if you have, say, X and Y here, and you put a sign here, because the sign faces the X, we say X is greater than Y. If you start to read from the Y, because the sign does not face the Y, or let me say that because it uses its back, its back to face the Y, because the sign does not face the Y, but it faces the X. If you have to read from the Y, you say Y is less than X. But if you have to read from the X, you say X is greater than Y. In the same vein, if I were to write something like this, X and Y this way, and then do this rather. In this case, because the sign is facing Y, we say X is less than Y, or we say Y is greater than X. So let's get back to what we were doing. And what were we doing? Of course, we were looking at the set Q. So Y is such that Y is greater than 3 but less than 8. So Y is less than 8 here. So what are the set of elements that are greater than 3? Okay, something greater than 3. All right, that should be 4. Something greater than 3, that should be 5. Greater than 3, in that order, 6. But I have to be very careful. That same something or the set should be less than 8. So 7 is greater than 3 but less than 8. That is true, but I cannot add 8. Do you know why? Because 8 is not less than 8. So the set of elements that are greater than 3 but less than 8, it starts from 4 and ends at 7. So that is the set Q, right? That is 4, 5, 6, 7. Now let me look at the last set quickly. The last set is the set that could easily confuse any student. It says the set of even numbers. You may think there is an infinite set. Of course it is not, because you have been told in the beginning that R is also a subset of the universal set 2, 3, 4, 5, 6, 7, 8. Now, what is the set of even numbers? An even number is a number that 2 can divide exactly without a remainder, or it's a number that is exactly divisible by 2. So of course you're going to start from 2 and then go to 4, you go to 6. Are you going to increase it just like that? 10, 12, 14, 16. The question is, where are you going to stop? You should not forget that we were told that the set PQ and R are all subsets of the set. So that means that you cannot have any element that goes beyond the universal set, and the universal set ends at the number 9, and the last even number in the universal set is the number 8. So that is to say, from 8 going, all these numbers or elements do not qualify to be part of the set R. So the set R is just 2, 4, 6, and 8, because you are told that R should be a subset of this set. Now the last thing that we have to do here is to find P intersection Q intersection R. That is the question. So which of these elements do we find in P? Then we're finding Q and R. Okay, that is P, so let us pay attention here. Let me use the blocking. So we have P here. P we have 2, 3, 4, 5, and that is Q. Q we have 4, 5, 6, 7, and here we have 2, 4, 6, 8. Right, there is 2 here. There is no 2 here, so 2 is not part of it. There is 3 here. There is no 3 here. 3 is not part of it. There is 4 here. I see 4 down here, and I also see 4 here. So the first element I'm seeing throughout is the element 4. Let me check 5 and see 5 is here. Do I see 5 here? I do. Do I see 5 here? No. 6 is here. 6 is there. 6 is not there. So of course you can see that the only elements that you can find in all the 3 sets is the elements or the number 4, and that makes D correct. So let me look at the options. So the option D should be correct, and if you look at the options here, we have 2, 3, 4, 5, 6, 7, 8, and then we have 4, 5, 6, and you should guess very well. Because of this, the set R is a set of even numbers, so you are finding the intersection. So the correct option must not have an odd number. We have even numbers. You are being told that you have a set P, which is less than 6, a certain set Q, which is also greater than 3 but less than 8. But the set R is the most important thing here. The set R is a set of even numbers. It doesn't have odd numbers, and we are talking about intersection. So there is no way that you can find an element or member that is in P and Q and R and it's an odd number. So because the set of R comprises only even numbers, it makes the option A incorrect. Even before you begin to solve, you must know that A cannot be correct, because in A we have 3 here, which is not an even number. We have 5, which is not an even number. We have 7, which is an odd number. In B2 there is 5, which is an odd number. So B and A cannot be correct. So the only potential correct options should be C and D. These are the potentially correct options. But if you check C and D, you can see that you can find 4 throughout here, but 6 can be found in only R and Q. There is no 6 here, so that makes D automatically correct. So I was just showing you how you can quickly solve your objective questions. The set R gives the clue that neither A nor B can be the correct answer. Of course, because you are talking about intersection, and there cannot be an odd number, because the set R is the set of even numbers. That is how to solve it, and thank you.